Well, Max here again. Welcome back to the shop. So today is a continuation on our JFMT lathe, and we're just going to be catching up on a few little fiddle fart jobs which tend to accumulate in between doing all the larger components on the machine. So yeah, it's just like little locks. It's all the little odds and ends. Plus, I'll also answer a couple of questions that a couple of guys asked in the previous video with regards to the taper turning attachment. So let's get into it. Oi. Someone brought up a point last week regarding the taper turning attachment here. There are a couple of points brought up. So the first one was the chap asked, how do you know your center height of your cross slide lead screw is going to be, in its correct position with regards to the rest of the attachment when it's bolted on? Well, basically you just got to hope that it is. There's no adjustment for that sort of thing other than maybe open up your holes or something like that. Now you do have a little bit of leeway in the fact that if your hole casting is slightly low, this slide here it's like on a boxway, so you've got a little bit of wiggle room, the slightest bit of wiggle room up and down, but not much. So we come out pretty lucky with our one, as we're not loading up the shaft. We'll put an indicator on and we'll just we'll show you. So yeah, this will demonstrate the clearance, or it's not actually clearance, just the fact that it's not binding. So we can freely wiggle that. If I push up, I can go right over here. That is loading it up. If I push down, she'll come back the other way with my finger. So yeah, she's nice and free. So it was a good point to bring up. So someone brought up another point too, is what stops the whole lot drifting, like your cross slide drifting in and out when the taper turning attachment's not in use, i.e. the end here is not clamped to the bed. Well, so you could get this carry on. Has a lock screw here, so you can lock it. Locks everything solid. Once this screw is locked in, the big slide here cannot move, and as long as you keep, I'll bring you in closer. Yeah, as long as you keep your adjustment up nice and firm on this gib strip here to take the play between this piece and the angle bar out, you're not going to get any play. So then you're down to your adjustment of you keeping up there on the end of your lead screw. It's that nut that secures the lead screw, not the opposite end where your handle is as per a standard lead screw. So yeah, it's just this lock here. Nip that lock up, pushes on the gib and locks this whole assembly. So let's get our cross slide backlash adjusted up. So the way that I do it is I'll bring that all the way back, generally thinking that that's one of its most unworn positions. Zero out our dial. So we've got approximately, well, 0.7 millimeters there. So we'll come across to midway, where you'd expect it's going to have its most wear, somewhere around there. Find our zero. 0.04 past 0.7, so just a tad over 0.7 still. Come down a bit further. Tad over 0.6. And that's right at the end. Yeah, tad over 0.6. Right, so that can be taken up quite a bit. Now bear in mind this is a two-piece lead screw, so we have a connection under here with a keyway. That play in here has got to be deducted from our backlash reading. So if I bottom out the cross slide all the way hard across, and then I check my dial now, so I'm getting 0.06 millimeters. I'll write that down. Now that 0.06 is the play in our coupled, our sliding key connection here. So we'll bring it off the nut. So we're back in our, so we just brought the cross slide in its unloaded position back here. So now we're back to our, where's our 0? Just under 0.6 of a millimeter. Okay, so we can take our slop out there. Right here is the tightest spot from midway to up this end to there. So at its tightest spot. So we'll bring you down. We'll go handheld for a sec. So on this particular lathe, these are the adjusting screws here. So the first two cap screws hold the major part of the bronze nut. The middle one holds, well, that draws up that horseshoe wedge, which is the adjuster, and spreads the nuts apart. And the end screw is for the minor part of the nut. Now this nut has the tapered face on it, which engages with the tapered face on the horseshoe wedge that's in there. This face underneath here on the nut is just a flat face. So we just slacken off that one, and while we wiggle our handle, we'll draw this one up. So I'll put you back in the stand. So what I like to do now is just, while I'm wiggling the handle, actually before I do that, I'll just lock the cross slide. Just makes it a bit easier to feel it. I'm going to draw this adjuster up, the wedge adjuster, until my backlash reduces right down to 0.06 millimeters, which was the number we recorded off the backlash off our sliding shaft in here. Which is there. So then I'll nip down the rear nut, slacken off our cross slide lock, just move it a bit at the back, and I'll check the backlash right at the back there. So we should have, we've got 0.07. So we have 0.01 clearance backlash right on our tightest spot. So I'll come back towards the middle. So in its middle position, we've got about 0.2 millimeters. And so that's close enough to about 1/8 thou approximately. Come all the way back. About 0.6. Yeah, about 0.06 there as well, which is back to our no clearance on the between the nut and the lead screw, and that backlash then was picking up the play in the connection on the two-piece lead screw here. So that's generally that's not in too bad a condition. So 0.22 was the worst. Deduct our 0.06 of the connection gives 0.16, which is tad over 6 thou wear at its worst point. So yeah, she's in pretty good shape. So before we put the cover on, this in here no doubt will turn into an absolute cesspool. So I'm just going to pack it full of petroleum jelly. I just want to take up that whole space. We're not going to have to get back in here again for a quite substantial amount of time, I hope. Yeah, so if you don't run flood coolant, it probably wouldn't be much of an issue, but I do, and I know it will grow a decent sized beard under there at some stage. So hopefully the Vassal, we'll see how it goes. Just off camera, I've just been going around tidying up a few small things, putting the locks in. I had to make up the new brass extension plug that goes in. That pushes up against the gib strip, runs between the gib strip and this lock here. That's all finished. So yeah, compounds, yeah, we're all pretty well finished up here. Cross slides all done. Now there was another one of this, another lock the same as that here to lock the cross slide, but I've substituted that for a bolt, as when the lock is in, or depending on what position this lock screws in, it can collide with the tailstock, and hence it knocks the end out of it. So yeah, that was how it was. So we've dispensed with that and just gone for a simple bolt, which is fine. I suppose next thing we better sort through our change gears. Try and remember where we were at with that, because that was a long time ago. So along with the change gears, we have the new stud shaft that we made previously, and the adapter that we sleeved with a bronze bearing previously to replace the worn out original stub shaft. So yeah, I guess we'll wander down there and get these fitted up. A bit of oil. So I think this goes this way. It's been a while. So that's the banjo where the change gears sit on, where the gear train mounts to. I remember it was a pretty neat fit. That's it. So yeah, we've got change gears go on here, here, and then complete the drive down to the feed box here. So I'll round up all the rest of the parts for this. I just got the oil draining out from the feed box. I remember when I very first drained this oil, there was some pretty white lumpy scum come out of it. So I've had a bit of 15W40 in it for the last, sitting in it for the last 8-9 months. So yeah, she's pretty shitty in there. So this is all the gear train mounted up now. That's that new shaft that we made. So just off camera, I just had to make up a few washers and all that were either missing or a bit dog-eared, and just make sure everything is in its correct alignment. So this lathe does have a pair of, it's a reinforced fibre gear here, which gives you a bit more quieter running gear train. Some will say, oh yeah, it's for if you have a crash and it'll snap a tooth off, but it gives you a quieter running gear train. So back to our feed box, and I opted not to pull the feed box out, as I did pull the pump out and got in there with some degreaser and all that and got out what I could. So I think it's come up semi-reasonable. So I've refilled it now with 68 grade oil, and I'm gonna run with it and just see how it goes. So I am running the same grade of oil in the Headstock as well. I'm only going to run it for a short amount of time with this oil in it, then I'll drop it out and I'll probably switch it out for a 46 hydraulic oil. So I've got the Headstock filter and screen apart, so let's go through this. So this lathe does have quite a good setup for the filtration for the Headstock oil. So it has this magnet, slips up into the filter housing. Get this all the right way around. And that's secured just by that little nut. We'll just give it a very light nip. Then it has this screen. It's a 100 micron filter screen, so I've just given it a good clean out. He slips up into place there, secured by a wing nut. Then there's a safety split pin. The old one didn't want to go in the hole, so I just grabbed a new one. Pop him in. Okay, O-ring. And the filter bowl. Just hand tight, it's all it needs to be. So make sure the label's at the back. Okay, so we should be able to spin the chuck over by hand and we'll see some oil come through into here. Well, we're half full, so we know our pump's pumping. Okay, so yeah, just working my way through the endless lists of the little wee details still on this machine. So what we have here is the button for the rapid traverse. So this assembly just bolts up on the end of the carriage here. There's wiring for it here. So originally it had this cheesy little affair here, but dodgy. So I thought I'll replace it with a proper button. And it's got a franger over the end of it, keep the coolant out. So it's a waterproof button. So what I have to make, because this is in a vulnerable spot where it sits down here, I don't want to accidentally hit it with my hand. that could be disastrous. So I'm going to make up a little shield for it, similar to what's on here, and the button will just clamp it in place. So I've got a bit of scrap material here I can get it out of. So I'll just give you a before and after. As all I'm going to do is cut this to length and maybe just bore 1 millimeter out just for a bit of extra clearance. So this is before and this is after. It's just a shield so we can easily operate the rapid traverse either longitudinally, or it'll also operate the cross slide. And I can't just accidentally hit it with my hand and activate it, so it's that job ticked off. Well, that's been good, being able to knock off a lot of these small fiddle fart jobs off the list of things to do. So I guess our next major one to go is to get this apron sorted out. So let's wander down and see what our plan of attack's going to be for that. So we have two main issues to sort out on the apron here. The first one is the crossfeed and traverse lever. Now this isn't on the traverse, it's not centering properly as it should. It feels very sticky. You want this to have a positive stop in the middle, so when you disengage your feed it is actually disengaging. So there's that. Now the original rapid traverse button I think used to sit up the end here when you just hit it with your finger. So the other job we have to do on it is this drive pinion. So this is in a very sorry state, so we have to manufacture a new drive pinion and its related shaft. It's a one-piece unit, so we'll get some material and we'll manufacture one of those. Now this does not have to be hardened. It's not soft, but it's not hard, so we'll just find a suitable piece of material, and then all the gears inside look to be okay, so we'll give the box a bit of a flush out, a good clean up, and then yeah, ready to be refitted, of course, after we make the new shaft. So we've got a bit of gear cutting coming up, and that's a metric, it's a module gear too. Now, just as a comparison as far as material selection goes when we make the new gear for the JFMT, this is the same gear but on our Dean Smith and Grace. So I wasn't sure like the hardness values or what it should be. So this gear here is probably, this lathe is 80 years old and there's next to no wear at all on this gear. So I just touched the end with a file and it actually feels like this is a cast iron gear. It's actually quite soft, but it's surprised me. After 80 years, there's no wear on it, no disconcerting wear anyway. There is a few thou, and that's it. So yeah, it was just, I needed something to just compare by, because if you make the gear too hard, all you're going to do is chop out your rack. So it's easier to replace a pinion gear than it is to replace or remanufacture a new rack. While we're on the subject of racks, yeah, not that kind. These are the racks off the Dean Smith and Grace. So these are quite substantial. These are 34 millimeters wide, would be inch and 3/8. So a little bit wider than the racks on the JFMT lathe. So let's go over to the JFMT racks. So the JFMT racks are about inch and 1/16, 27 millimeters sort of width, and a slightly smaller pitch gear teeth on them as well. Now, what I suspect may have happened, why that pinion off this machine is in such poor condition, when you have a new lathe, these racks have a wax or their protective coating on them. Now, if that's not thoroughly, properly cleaned off, you get a lot of debris and trash sticks to them, and it wears like, it's like grinding paste. It goes like, so I suspect that's possibly what's happened to this one, as when I did do the cleaning on the lathe, I noticed down the far end of the rack there was still a lot of that waxy, that protective material on the rack. So I've since had all these racks off and given them a really good clean. And what I did try to do, I was trying to see if I could fit the new racks, which have never been worn, up the end of the lathe, up to the front, and like reposition the whole rack system. Like put the front to the rear and the rear to the front, but it doesn't work. Where they sit, they can only be bolted on in one position. So yeah, I thought that was a bit unfortunate, but you get that. So before we close this one out, I'll just give you a quick peekaboo of what I've been up to on our delightful, sexy, gorgeous Dean Smith and Grace lathe. So I think last I mentioned I was doing some preparatory cleaning on the bedways in preparation so we can get some measurements and just see what wear, if any, is on these flatbed ways. So I've been using brake fluid, sorry, not brake fluid, automatic transmission fluid. Now generally I would use that mixed with acetone, but I've run out of acetone. So it's, the ATF has done its job a little bit, and I'll just try something else. So I'll give CLR a go on a short section here. So you can see the rust staining here, and then for about 5 inches across here, you see it's come up very well. So that's had 2 doses of CLR, just very lightly scrubbed in with a small brush, like a toothbrush. Now the remaining 2 feet has just had one coating of the CLR. So I was just sort of experimenting a bit just to see what would happen. Now there's another channel that I watch, and possibly some of my viewers may watch him as well. It's old DD from Washington. I think he's, yeah, Washington. Walla Walla. So he uses a bit of this stuff here. Apparently it's called hair tonic. Yeah, I don't know what its true use is. Well, we can't mention that on YouTube anyway. So he has good results with this. So I'll try a section and see how the hair tonic works. So yeah, old millwright. Plenty of tricks up those old guys' sleeves. So next video, yeah, we'll just see how the hoppies has performed. Okay, well I think we'll wrap this one up here, and yeah, next video we're going to get into the apron of the JFMT, and like we've just mentioned, we'll see how the hoppies, or hops number 9, how that performs on this rust stain. So I do want to get all of the rust stain out, as I don't want it, I don't know if it would have the effect later on of it coming loose with general use and flood coolant and that sort of thing, and acting like sand or abrasive grit in between the bedways and the carriage when it slides up and down. So that's my main aim, is to get it all out. So anyway, cheers, thanks for watching, and we'll hopefully catch you in the next video.